The environment represents the whole ecosystem that a society depends upon for various services, such as water, materials, food, and energy. In our analysis of the environment, we are really looking at a combination of natural ecosystem and human economy. What is called a socio-ecological system, which is a model that helps to focus our attention explicitly on the interactions between our engineered environment and the natural environment, and how the two function, or fail to function, as an entire system. The nature of socio-ecological systems has changed fundamentally over the course of human history, as we have developed new technologies, institutions, and tapped into new energy sources. The adoption to the practice of agriculture, some 8,000 years ago, represented the first fundamental change in this dynamic, as we created systematic processes for harnessing ecosystem services, based around the technology of farming and the power of animal muscle. This socio-ecological structure changed again with the rise of industrial systems of technology during the 1800s, as the new energy sources of fossil fuels and mechanical technology drove a new form of mass production in industry. With farms becoming more productive, the mass of people were liberated to move into cities. With this transformation, traditional bonds between environment and society became permanently dislocated from their indigenous form. Many of the processes of change that began with the Industrial Revolution reached a takeoff point in the mid to late 20th century, as almost all indicators for economy and ecosystems started changing at an exponential rate, from population growth to loss of species to energy consumption. This great acceleration of economic activity has given birth to a new geological era that scientists call the Anthropocene, as human industrial activity has become the primary driver of changes within Earth's systems. The Anthropocene represents a new form of socio-ecological system, one that is truly global in nature, with an unprecedented scale of alteration to Earth's core systems such as overall biodiversity, climate, and ocean acidity. Within the course of just a few decades, we have transitioned from being a small world on a big planet to being a big world on a small planet, an extraordinary transformation. A switch from making ad hoc interventions into ecosystems to becoming the primary drivers of change within the biophysical processes of the entire planet. A truly profound transformation in our socio-ecological systems, one that we are far from understanding the consequences of, but nowhere are these consequences being made more acutely explicit than through the changes in climate. Climate change reveals many dimensions to the new reality of the Anthropocene. Through human industrial interventions, the feedback mechanism that stabilizes and regulates Earth's systems have become significantly degraded, both within local ecosystems and increasingly on the global level. The breaking of these stabilizing negative feedback loops increases destabilizing positive feedback that makes the system more unstable, and thus generating more extreme events, what scientists call global weirding. We have benefited for over 10,000 years, since the beginning of the Holocene, from Earth regulating itself to create an environment conducive for human economic activity. The Anthropocene is a recognition that this stable geological era has ended, that because of human intervention, the biosphere can no longer stabilize itself within the same equilibrium that has benefited societies in the past. That the global economy is now the primary driver of change within ecosystems, and if we want the service of a stable environment, it will have to derive from an appropriate economic model capable of regulating those ecosystems. Generating an appropriate response within our economic systems of organization to this profound transformation will clearly not be a business-as-usual scenario. Our traditional approach to macro-scale environmental management has been exercised through a top-down centralized model, driven by government institutions and based on the paradigm of environmental conservation. But this is no longer relevant in an age when industrial activity has become an embedded part and central driver of change within virtually all ecosystems around the planet. Ecosystems management can no longer be an ad hoc solution patched onto the side of the economy. This new context requires that it become a central part of what the economy is and does. Economies function as distributed management systems. Through the negative feedback loops of the market, they manage whatever it is that people value, can quantify, and exchange. Until very recently, we have only really valued the derivatives of ecosystems, the water, food, minerals, etc., in terms of their utility to which we could ascribe a financial value. But this is changing as we build a new kind of post-industrial economy with a more complex multidimensional conception of value. Completing the process of industrialization means people's values change subtly, but importantly. At this stage in economic development, the scarcity is no longer in technology, capital, and labor, it is increasingly in natural capital. The value shifts from the derivatives of ecosystems to the functional integrity of those ecosystems. This integrity of the ecosystem can't be fully measured in terms of utility. It requires a different kind of capital, what can be called natural capital. Using economic and business models to manage ecosystems means firstly understanding those ecosystems and the value of their integrity, which is a significant scientific challenge. But from this can be derived some form of evaluation system and accounting mechanism. Ultimately, this means building a new dimension to the economy, a new value system for the quantifying, exchanging, and accounting for natural capital. Also ensuring that management systems actually correlate to the underlying resources being managed. This new capability is already emerging in advanced economies, though largely unconsciously and in a very piecemeal fashion. But it will undoubtedly form one of the primary dimensions to our economy going forward. Because economies are always about people and what they value, as the context changes, as those values change, and as the nature of the resources that need to be economized changes, so does the economy adapt. But this adaptation won't simply fit into our current economic model. It will require the system evolve into a more complex form with the new capability of natural capital accounting. In our paper, we trace a number of different dimensions along which advanced economies will change in the coming decades, as this new environmental context continues to unfold rapidly. We look at a number of different business solutions and changes in business models that will enhance their relevance in this emerging economy of sustainability. Primary among these is the need for businesses to begin natural capital accounting in order to prove commitment to their customers, add value, and maintain relevance and differentiation. This is an inherently complex task that requires businesses to ask difficult questions about their supply chains. Companies like Puma have already achieved this, while larger organizations like Walmart, with tens of thousands of products and suppliers, are gradually moving towards implementing natural capital accounting across their entire supply chain. Building a new dimension to the economy requires harnessing the resources of the mass of end users. With information technology, end users are more informed, engaged, and empowered than ever. Centralized organizations can no longer do it alone. Harnessing the resources of the crowd means building collaborative platforms, networks that aggregate these distributed capabilities, that create communities through social networking technology, and use different forms of gamification in recognizing, enabling, and harnessing people's aspirations and intrinsic motivation towards giving meaning and value to the natural capital economy. Circular business models will be a key part of any future set of sustainable solutions. Our economies are in effect predominantly made up of waste. As one commentator said, this is the biggest business opportunity in the history of civilization. Never have we generated so much waste. It is literally everywhere in heating and cooling, in moving and housing, in packaging and food supply. To tap into this circular economy, it takes the intelligent design of feedback loops to reconnect these linear dead-end processes back into other systems for reuse, recycle, repair, refurbish, etc., obtaining multiple points of value from resources that currently only offer one value proposition. To take full advantage of the circular business model means also shifting to a service paradigm. The two go hand in hand. The services business model is focused on selling solutions and outcomes instead of products. This has many beneficial advantages for customers and environment as it works to aligning all interests around a reduction in the material and energy consumption required to deliver the same level of service. The services model works to straighten out current misaligned business incentives, which are at the heart of creating many of the negative environmental externalities of consumer society, while incentivizing companies to focus on relentless innovation and resource efficiency in their service delivery processes. Finally, a changing environment will require the new capacity of adaptation and resilience, both for individuals, companies, and for entire economies. Resilience and adaptive capacity are a new set of capabilities that are significantly lacking in our current industrial solutions. Resilience is not the property of a thing, it is the emergent phenomena of a network of connections between things. It is how that network can stretch and bend in adapting to the stresses applied to it. Building resilience to environment change is primarily about engaging the distributed local capabilities of the organization in a bottom-up fashion to build local resources, and through that, autonomy and adaptive capacity. This is a very high-level overview to some of the analysis presented in our Environmental Solutions Report.